Most of us think naturally in terms of angles with degrees. Now, what we want to do is try to develop the idea of radians. First of all, addressing what is a radian, and then what we want to do is to start naturally thinking in terms of radians and let that complement the concept of a degree. In fact, a lot of what we do in this course, it's better for us to think in radians because of some of the advantages of radian measurement. So first of all, what is a radian? A radian is a measurement for angles, but it's defined differently than a degree. What we know for degrees is there's 360 degrees in a circle, and when we understand that 1 degree is pretty small, 90 degrees maybe looks like this, 180 is halfway around the circle, and 360 is all the way around a circle. So when we say what is a radian, I want us to picture or think about the term radius wrap. Now, that sounds abstract to start, but let me show you what I mean. So I want you to picture a circle, and then on this circle, I want you to picture the radius. Now, this radius is a segment, right? So the radius is about like this. Now, what I want you to do is picture that same segment length kind of going up. Now, my circle's a little lopsided. Maybe I can fix that just a little bit. Maybe my circle's a little lopsided there. Okay, that's a little better. Not the greatest artist here. But when you think about a radian, 1 radian is the idea of 1 radius wrap and then the angle that is created. So if you had 1 radius, that's the same distance, just oriented up. Now, what I want you to do is imagine that little blue segment folding on top of the circle and then picture how far it would go. So maybe it looks something, as we fold it down over our circle, something like this. So now picture the angle that is created. That angle was created by 1 radius wrap. That angle is 1 radian. So I'm going to just draw this picture. And that is 1 radian. That angle is 1 radian, 1 radius wrap. Now, I want to picture the same thing again, and I want you to picture what it would look like to have 2 radius wraps. So this time, maybe I'll change it to green. 1 radius would be about like this, maybe a little shorter, and then 2 maybe about like this. So if I fold that green segment down onto the circle and wrap it around, I look something like this. So the angle that I create for 2 radians is bigger, right? Definitely bigger than 90 degrees. And that is about 2 radians. We can abbreviate RAD. And in fact, we can think about when we talk about radians, you don't actually have to put the unit. So if you just saw something like theta equals 2, the angle is 2, and it has no unit measurement. It doesn't say radians, but it also doesn't say degrees. You can assume that 2 means 2 radians. So 2 radians is the angle that's formed by 2 radius wraps. Now, another way to describe this in terms of a formula is that the angle that you have takes the distance along the top, or a distance of that arc length, and counts the radius wraps. So the arc length is the distance along the edge, almost like circumference, but a partial circumference, and you divide by the radius. So the radians measure how far you go in terms of the radius, or the number of radius wraps. All right, so when you think about this sort of a picture, or this sort of a formula, then you can also think about going all the way around the circle, kind of what that might look like. So I want you to think about if you had an arc length and you, instead of just going partially around the circle, you went all the way around the circle. All the way around the circle would be an arc length of 2 pi r. You can kind of think about if you went all the way around, that's like a circumference. So if you're thinking about all the way around the circle, that's 2 pi radius. 2 pi times the radius. And then when you divide by the radius, the angle that you get out is 2 pi. So when we think about this picture, this is like all the way around the circle, or one rotation around the circle is 2 pi radians. So here, what we want to think about is trying to compare radians versus degrees. So I'm going to write some comparison up top, and then we'll look at another illustration. So if we had, maybe we'll squeeze it in here. If we had 360 degrees, this corresponds to 2 pi radians. If we had 180 degrees, that's like pi radians. And I want you to also start to think about, instead of writing 2 pi, we can also start to think about the radian wraps in terms of decimals. So let me show you an illustration, and then we'll come back to those decimal ideas. So on this illustration, I'm going to move this point around the circle, and it's going to show you the radius wraps and kind of keep track of the decimal version down here. So what I'm going to do is move this red dot until we're about 1 radius wrap. So I'm going to try to get it right there. There's 1 radius wrap. And notice that if you see 1 radius, that's about what we were seeing here. So you can see that 1 radius wrap, or an angle of 1 radian, is about 57 degrees. We'll kind of come back to that idea as well. But if we go to 2 radius wraps, or 2 radians is about 115 degrees. We can think about 3, there it is, about 3. That's a little bit less than pi, right? Oh, sorry guys, I think that's covered up just a little bit. Oh, I circled the wrong one too. Let's get rid of that. The 180 degrees, oh, I think it's covered up with my red here, or my black part there. 180 degrees corresponds to pi radians. But if we wanted to write it in decimal form, that would also be the same thing as about 3.14 radians. In other words, if I kept going past the 3, there's about 3.14 right in here. And notice you're about 180 degrees right there. So what we want to think about is going around the circle. It's 2 pi, but 2 pi is about 6.28. So it takes about close to 6.3 radius wraps to make it around the circle. So we want to think about that 360. Sorry guys. The 360 is also 2 pi, or about 6.28. So what we want to do coming up is we want to get fluent in converting. So we want to be able to take a measurement in terms of a degree and convert to radians, and then radians back to degrees.